Hi, in this video, we'll be continuing the H2 Math 2021 Paper 2 question 4. So for question 4, it is testing you on your abilities to model real life situations and determine and solve geometric and arithmetic progression series. So let's see how do you model the question. So we just need to take it step by step. That's the first aspect of it. So we just take it step by step and we'll be able to solve it. What do I mean? Let's see. Mrs. Wong devises a training program. Then the members are supposed to swim 10 laps. Then the time taken to swim the first lap is 40 seconds. And the time taken to swim the last lap is 25 seconds. And they are in an arithmetic progression, meaning it's 40, then something, 40 plus something, 40 plus 2D plus all the way until you reach 25 seconds. The question now is to find the total time it takes. So it has to be 40 plus D plus all the way to 25, and we have 10 terms. But in the arithmetic progression, it doesn't really matter what this D is, because we already know the formula is n over 2 times first term plus last term. So you just need to take the number of terms divided by 2 bracket first term plus last term. So it's 3 to 5. Next, one of the members of the club devises another plan, and the first lap is 25 seconds and the last lap is 40 seconds. And now it is in geometric progression. So instead of going faster, this person goes slower, and the way it increases is in a geometric progression. And now someone swims 30 laps, 10 of them using Mrs. Wong program, and then another 10 laps using a constant speed of 25 seconds, and the last 10 laps using Alfie's program. And the length of the pool is 35 meters. So we're supposed to find the average speed. And so average speed, is total distance divided by total time. So we need to first find the total time, as total distance is easy, it's 35 times 30. So we just need to calculate the time taken using Alfie's program, which is, so we just need to take 25 plus 25r plus 25r squared plus over 40. But now using the geometric progression formula, we know that we cannot do this first term last term addition anymore, and we actually need to find the common ratio. And to do so, we need to recognize that 40 is just 25r to the power 9, because 40 is the 10th term. So r is actually 40 divided by 25 root 1 over 9. So that's this. And then, so the formula for geometry is a bracket r to the power n minus 1 whole thing over r minus 1. So r in this case is this, and r to the power 10 will be this formula, this value, and we're able to see that it's actually 319.798. And so the total time, you got to take this Alfie's time plus the earlier time that you found plus the constant speed time, and you see that it's 894.798. and so the average speed is taking the total distance divided by the total time. So the total distance divided by the total time, which is 1.17. And now we're supposed to determine exactly 8 minutes after she starts swimming, Susie is swimming away or before. So this is really just mathematical modeling. It doesn't really has any formulas. So we just need to see 8 minutes is 480 seconds, which is more than the 3 to 5 seconds. So it's definitely in the constant speed part already. So if it's in the constant speed part, we know that there's only 155 seconds left, but the constant speed lasts for 225 seconds. So it must it must still be in a constant speed lap. So you can just take 155 divided by 25, and so it's 6.2 laps. So you go 1 lap, 2 lap, 3 lap, 4 lap, 5 lap, 6 lap. Then 0.2 will be this way, so it's swimming away. I hope that's clear. For question 5, now we're supposed to do integration, and we are supposed to integrate tangent squared 5x. So the thing is, we know how to integrate secant squared, and we are able to convert tangent squared to secant squared using the formula. So we convert tangent squared to secant squared minus 1, and then we just integrate secant squared to be tangent 5x times 1 over 5, because here got 5 inside, so we need to times 1 over 5. Then we integrate the minus 1 to plus minus x, then we add a c. And for the next one is sine 2x, sine 3x integrated from 0 to b. So the trick now is to use the factor formula, because it changes a product which is hard to integrate into a sum or a difference in this case. So in this case, because it is a difference, so we are able to integrate one term at a time. So that's the usefulness of the factor formula in integration. You converted a product into a sum for easy integration. So you just need to integrate this, which is easy, which is just 1 over 5 sine 5x. Then this is just sine x. Then you input the values from b, and then you minus the values that you input at 0, and you should get this answer. For part C, now we're supposed to integrate from 0 to b of 1 over x ln x. And in this case, we know that 1 over x is the derivative of ln x. So if we just ln, it's like this formula. Then this is just ln fx. So it's actually just ln x, and then it's from a to b. Then you just need to sub in and you get this answer. So this should be very clear, but it's just to recognize that 1 over x is the derivative of ln x, and ln x now is a reciprocal, so you just need to use the formula for integral of fx derivative over ln x, which is ln fx plus c. So given the substitution, now we're supposed to integrate this. So basically this whole question is just testing you different ways of integrating and techniques. So now we're going to integrate this. So using this substitution, we see that we have e2x here. So that's just this e2x will actually be removed later on, because if you see, we need to change this dx to a du. So we need to find the du dx. So du dx is 2e2x. This results in du equals to 2e2x dx, supposedly, which you don't write down. And this means that 1 over 2e2x du equals to dx. So this part you don't write down, but you just take note. So now you know this dx, you just sub into here. So then this e2x will cancel out, which only leaves the half. So that's why I put a half straight, and I integrated 1 over. This part is just u cubed. And this part you can integrate normally, because this is just a rational function. So it's just u to the power of minus 2 divided by 1 minus 2. So you get this answer. Remember to always sub back your u as the function in terms of x. For question 6, we have a biased 5-sided spinner giving us the score of 1, 2, 3, 4, 5. And there are probability P and Q which are constants. And given the variance of the score to be 1.68, we're going to calculate the mean. So this is just a tedious question, but very straightforward. We just need to find enough equations to solve for the unknowns. So first equation that we know is that we add all the probabilities up, it has to be 1. So this gives us the equation to write Q in terms of P. Next, we find the expectation, which is actually the mean. So we just use the formula. So it's 0.2 times 1 plus 0.3 times 2 all the way. And we're able to simplify it when you sub Q back into P. Q over here as a term in terms as half minus 2P, and you get 3.3 minus 3P. Then you also find 3E x squared, which is 13.9 minus 25P. And variance, you know the formula is EX squared minus EX whole thing squared. So you just get this quadratic formula. And this is now equals to 1.61, which using your GC, you're able to solve for P equals to 1 over 5 or P equals to minus 7 over 9. But then this has to be rejected because probabilities has to be positive. Then this allows you to find now the expectation because you sub P as 1 over 5 over here. So this question might seem long, but it's actually a more tedious question. But if you stick to what you know and you just use the information given, writing one of the unknowns in terms of the other unknown first, finding the expectation, you want to find the variance in the end, so you need the expectation EX squared, and then you solve for it using your GC, you're able to do it swiftly. Now, question 7 is a combinatorics question, and so the question starts with a magician performs a trick, says the word abracadabra, and there are 11 letters arranged in a row. So how many arrangements can it be? Well, because they are repeated, the trick to doing it is see how it is how many letters are repeated. So you put A, so you start A, then you just get A, then B, then C, R, then now you got A and repeated, so you do this and you keep doing it and you write this in the end. So the number of arrangement must be the total letters, which is 11 factorial over 5 factorial because it's repeated, 2 factorial, 2 factorial, and you get 83160. And next, we're supposed to find the number of different arrangements in which two B's are next to each other. So two B's are next to each other means we have to group the two B's, and the two R's are also next to each other, group the two R's, and there are exactly 4 A's next to each other, and the C is next to the D. So the C is next to the D is grouped together, and exactly 4 A's are next to each other means we can group the 4 A's here. And so the idea is now we need to arrange this 4 blocks first and later slot in the A. So you arrange the 4 blocks already, is just then after arranging the 4 blocks, you need to, which is 4 factorial, then times 2 factorial because CD can be DC also. Then you can choose 3 slots only to place where your next A is, because it cannot be placed here or here. So that's why it's 3 choose 1 times that the arrangement earlier, which is 144. So the trick in doing this is you are able to clearly group the terms together and arrange this grouping first before slotting in the A, because A cannot be next to something else, so you need to choose wisely where you want to slot it in. So you arrange the rest first, then you slot it in. As for the last part, we are given that the letters are arranged randomly. Find the probability all 5 A's are together. If all 5 A's are together, this whole part becomes like one chunk, so it's just 1, 2, 3, 4, 5, 6, 7. So you got 7 blocks now, 7 factorial over 2 factorial, because this is repeated and this is repeated, 2 factorial over the total number, which is here, and it gives you 1 over 66. So I hope this is all clear, and we have come to the end of this video. I hope you have enjoyed it, and you can share with your friends if they like and if you like. I'll catch you in the next one. Bye.